Welcome back to our YouTube channel. My name is Nawasa Rodrick. Our project AI prediction project. Me and my colleague Guy was Steven. So in these slides, we're going to talk about exploratory data analysis on your data set you chose for your project. So yeah, uh, these are the procedure. The procedure we first did was we had to first import the different libraries that are going to help us in our project. There's NumPy, there's the first one, import NumPy as NR, Pandas as PD, Seaborn as NSA, OS, Mat, Mat, Matplotlib, everything here. So this is the code you have to follow to get the different data. Then we're required to make a heat map of the data set. A heat map is a plot of, of rectangular data as a color encoded matrix. As parameter, it takes a 2D data set. That data set can be converted into an array. This is a great way to visualize data because it can show the relation between variables, including time. Yeah, the heat map helps you to visualize the volume of location stroke events within the dataset and assist in direction viewing towards areas on data visualization that matter most. So in our on our heat map here, it is showing us the different IDs for the odds, and there's the home, away, and draw. Then there's a correlation matrix. A correlation matrix is simply a table which displays the correlation coefficients for different variables. The matrix depicts the correlation between all the possible pairs of values in the table. It is a powerful tool to summarize a large data set and to identify visual, the visualized patterns in the given data. So this is the code. So core is equal to df was our data set variable name dot core, and it comes out here. This is the method to find the correlation of each column on the data frame. Box plot. A box plot is known as a whisker plot. It's created to display the summary of the set of data values having properties like minimum, first quartile, median, third quartile, and maximum. So the steps: set the fig size, and adjust the padding between and around the subplots. Make a pandas data frame with 2 columns. Um, then you plot a frame using plot method with a which kind is equal to the box plot. To display the figure, you use the show method. So the box plot here, it is used when showing the description of data points across the selected measure. The, the display ranges within the variables measured. So our display, it ranges between the variables of the away, home, and draw. So yeah. Then the feature independence plots. This is a diagrammatic presentation of a group of data over used specialized ranges. Basically, the histogram contains several bins. Bins are non-overlapping intervals in which the data is spread. Yeah. So these feature independence plots are used to show the relation between features and predictions. So yeah, this is the features. This is the code, the variable name again, df.hist. Then this is the one for away, uh, draw, away, home, yeah. Then the outlier plots. Outliers are data points that differ from other observations or those which lie at the distance from other data. They are mainly generated due to some experimental error, which may cause several problems in the statistical analysis. An outlier is a result of some errors in, in some data points. The, the dependent variable, which is home, is concentrated more within the range of 1.0 of approximately of the feature away, as shown in the graph. The points over 1.0 are clearly outliers, resulting in disproportionate statistics regarding the overall structure of the data. As a result, we may create scatter plots for all the datasets attributes that we anticipate may contain outliers. So yeah, this is how it looks like. The outlier, the scatter outlier is a point or points are that are farthest from the regression line. This is the code here. You first import the library matplotlib.prto as this. Then yeah, you insert the variables home versus away here, and this is how they come out to look like. We did different of them. Home versus away here. Here we did away versus draw. Then here it was home versus draw. Illustration of trends in time and space. Trend is a pattern in data that shows the movement of a series to relatively higher or lower values over a long period of time. A trend is observed when there is an increasing or decreasing slope in time series. Trend usually happens for some time and then disappears. It does not repeat. A time trend is the ordered set of natural numbers that measures the time span between observations. The slope of a time trend line represents the growth of a variable. So steps in determining a time trend. You import the libraries, load the dataset, change month column into data type, you plot and visualize, then you check for the trend, you check for the seasonality, then the smoothing and fitting a function. So yeah, this is it here. Time and graph is a data visualization tool that illustrates data points as successive intervals of time. Each point on the chart corresponds to both at the time and the quality that is being used. Yeah, as this is the code here. You import the library again. Then here, using an inbuilt style to change so it look and feel the plot. So this is the size, the fixed size of the time and space graph. These are the different variables, the date, values, yeah. So we use the this is the data, the database name and the dataset name df and one of the variables to in order to come up with a time and space graph. Then data processing. Data processing, we divide our data set into training set and test set. This is one of the crucial steps of data preprocessing, so we can enhance the performance of our model. Training set, a subset of data set to train the machine learning model, and we already know the output. So then the test set, a subset of the data set to test the machine learning model by using the test set model predicts the outcome. So this is the code, the process these are the different steps we took. We first assign the variables, x is equal to the data set drop. Then we import a library from this import train set split. This is it here, and this was the outcome. Then after that, after initializing our variables, we split data into the train, validation, and test sets. Data splitting allows unbiased valuation of the model's performance on the fresh data that was not previously seen by the model. Now, particularly if the full data set is split into a training set and the training set using an 80/20 split ratio, then the model could be built using the 80% data subset. This is called the training set, and it is evaluated on the 20% data subset, which is the test set. In addition to applying the trained model on the test set, we can also apply the trained model on the training set. This data is used to construct the model first. The comparison of the model performance of both training set and test set always allow us to evaluate whether the model is underfitting or overfitting. Underfitting occurs when both the performance of a training set and the test set are poor, whereas overfitting this is when it's underperforming when compared to the training set. This is shown in the next slide. So you can see a model building. We used linear regression as our model. Um, this is the code here, linear regression. Now that the model is built, we are going to apply it to previous predictions on the dataset as follows. This was it here in the code. So the model performance, we're going to, we're now going to calculate the performance of the metrics so that we are able to determine the model performance. Yeah, this is the code we used here. Then the performance metrics can be displayed by simply printing the variables. This is if you want to get the outcome, yeah, to display what, yeah, for one of the what the training set has come up with. So another way you can use the 3D display with the four metrics are shown here below. This is it here. So the result, if you want to get the result, you can type the name, the variable name, which is ln, then underscore results, and you come up with the results here. Our results tell us the training set that is here and the test set here are all linear 1.0, 1.0. Then there's data visualization of prediction results. We can now visualize the relationship of the actual Y values with the predicted Y values experimented. So here again, yeah, you import this. Then we already imported them though. So this is how you're going to do it. The code, the various code. This is the predicted array, experimental array. Yeah, this is comparing the predictions and the predictions we expected, and then what we got after experimenting using our data set, and everything is linear. So this is it. Thank you guys, and have a good day. Subscribe to our channel.